Welcome back to math. How are you guys doing tonight? It is wolf years since I was just at Great Wolf Lodge. Figured these would work for our video. We're spending some more time writing equations in slope-intercept form, but this time instead of having the slope and the y-intercept, we have to figure them out from a verbal description. So you guys can go to page 229, 229 in your books, 229 in your books, and follow along as the video plays. There's some spots on page 229 for you to fill in. So watch this and fill in those pages.
You can write an equation in slope-intercept form to model this relationship. Bamboo is one of the fastest growing plants on Earth. Suppose a bamboo seedling is 5 centimeters tall and grows at a rate of 6.5 centimeters a day. In the slope-intercept form of an equation, m is the slope and b is the y-intercept. The slope represents the rate of change. For the bamboo plant, this is the change in height, 6.5 centimeters, divided by the change in time, 1 day, or 6.5 centimeters per day. Next, find the value of b. b is the y-intercept. This is the initial value, or the initial height of the bamboo plant, 5 centimeters. Substitute the values for slope and y-intercept in the equation. Substitute 6.5 for m and substitute 5 for b in the equation. The equation in slope-intercept form for this relationship is y equals 6.5x plus 5.
Okay, so there's one example. Let's look at another one, and this is on page 230, so you can follow along on page 230. 230. Kind of sounds like a howl, right? Okay, so here's the problem. Student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. Write an equation to represent the total cost y for printing any number of shirts x. So if you think about this, we need two things. We need a slope and we need a y-intercept. Well, again, slope is the rate of change, or our unit rate, kind of like a unit rate, but it's not quite a proportional relationship, but the cost for one t-shirt. So it costs $5 to print each shirt. So that's going to be our slope, because for each shirt we're going to pay $5. But we also have our initial cost. So the one-time charge for the design is $20. And then if we use this as our slope and our y-intercept, if we just plug in 5 for the slope and 20 for the y-intercept, then we get y equals 5x plus 20. Now if you think about this, if I'm printing shirts and it costs $20 for the design plus $5 for each shirt, this should make sense. So if I buy 2 shirts, it's going to cost $20 no matter how many shirts I buy, but then $5 for each shirt. So 20 plus 5 times 2, which is 10, so $30. If I buy 50 shirts, then it becomes a little bit more reasonable, because we still just have this one-time cost, and then we pay $5 for each of the 50 shirts. So hopefully that makes sense. The slope is kind of the rate of change. We're paying an extra $5 per shirt, and then your y-intercept is always, if x is 0, if I buy no shirts, what is my cost going to be? Let's look at another example. This one's not in your book. You don't have to write this down, but just follow along. So think about it. These you can even do without necessarily thinking of slope and y-intercept. So let's just think about if I were going to write an equation. Mark works in an aquarium and cleans the fish tank. In order to clean each tank, he drains the water. Each tank initially holds 180 gallons and is drained at a rate of 2 gallons a minute. So initially we have 150 gallons. So this here is my y-intercept. What do we start out with? And then it is drained at a rate of 2 gallons a minute. So what do you think our slope would be if it's drained 2 gallons a minute? And then our slope is going to be -2. So we would say y equals negative 2x plus 150. So it's the same thing we were doing in the last part, where once we have the slope and the y-intercept, we just plug those in for m and b. But first we have to figure out what is the slope and what is the y-intercept based on the information. So think about this. Every minute, if I have 1 minute, that would be negative 2. Negative 2 plus 150 is 148. So if I start out with 150 gallons and I go down 2 gallons, that's 148, then 146, and so on and so forth. So this equation kind of models and represents that situation. So you guys pause and do the check problem at the bottom of page 230 and see if you can figure out what is the equation for that check problem at the bottom of page 230. Okay. So now that you've done that, I know you all paused and did the problem, which you should be doing because I'm checking those as part of your homework. That is your practice along with the video. Taking notes, doing the check problems, watching this, all of those are the things you should be doing. All right. Last thing is writing equations in slope-intercept form from a table. So again, we've seen several tables already. We have the x-coordinate, which is time in this case, and the y-coordinate, which represents distance. So we did this before where we find the change in the y. We're going up 12 each time. Here we're going up 2 each time. So the change in the y is 12 over the change in the x, which is 2, and 12 over 2 is 6. So the slope is 6. So we talked about finding the slope from a table in a previous section. But I want you to see where the y-intercept is on a table. The y-intercept, anytime we have a y, oops, that's weird. Okay, interesting. Anytime we have a y-intercept where it crosses a y-axis, you think about this, any point on the y-axis, what is the x-coordinate of any point on the y-axis? The x-coordinate is always going to be 0, right? So from a table, anywhere where the x-coordinate is 0, that is a y-intercept. So my y-intercept is 10. So slope we found using 12 over 2 to get the 6. And then the y-intercept is 10. And once you have those two numbers, it's really easy to write the equation. You just plug 6 here, 10 in here. Let's look at another example. So Amanda is reading a novel for her language arts class. The table shows the number of pages that Amanda has left after a certain number of hours she has spent reading. So this is how many hours she's read and how many pages left. And notice that the pages go down as the hours go up, which hopefully makes sense. Now if we look at the chart, let's go back here. If we look at this chart, what's happening to the hours? It's going up 2, up 2, up 2. And you can follow along. This is on page 231 if you didn't see it already. And this one, what's happening here? We're actually going down 80 each time, down 80. Okay, so x is going up by 2, but y is going down by 80. So if you look on page 231, the change in y is down by 80, it's negative 80, and the change in x is going up by 2. Remember, it's always y over x, 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 y over x. And then simplifying that gives us negative 40. Are you working? Do you want to work for me? No, you do not. Okay. Only works when I take it there. Okay. There we go. Negative 40. Now we have our slope. So our slope is the change in y over the change in x. And then we need our initial amount. So our initial amount, or our y-intercept, is when x is 0. So our y-intercept is 360. now we have our slope and we have our y-intercept, so then it's back to what we did the day before. Plug it in. Slope is -40. Y-intercept is, I forgot what we just said, 360. And so there is our equation here. It is -40x plus 360. So as the time goes by, if I plug in 1 for x, this is going down 40 pages. If I plug in 2 for x, it's going to go down 80 pages from the initial size of the book. Does that make sense? Hopefully, kind of, sort of. In the next section, we're going to be graphing these. So you guys see if you can figure out the check problem in the middle of page 232. And we will stop there for today. I hope you guys have a howling good night, and I will see you tomorrow.